Hello everybody, my name is Professor Math and I'm going to be teaching you how to find the slope of a triangle. Alright, so here we go. This is going to be the triangle that we have. It is backwards, so I'm just going to illustrate really. So on the bottom here we've got 10 centimeters and over here we have 7 centimeters. So the first thing that we are going to do is figure out which one is the rise and which one is the run. And so the best way to explain it is the rise is here because it is going up, and when you go up you rise. And this way is called the run because it is the horizontal distance, and you can just imagine yourself running away from math class right there. So knowing that, you're going to move on to the formula. Slope equals rise over run. So again, this is rise and this is run. So if we do it step by step, it will be something like this. Slope equals 7 out of 10. And you don't have to divide that at all because it's really just a ratio. There's no unit of measurement or anything there because it's 7 to 10 essentially. So you could even write it out like a ratio, just like that. And that's how you find slope. So, that being said, there might be a couple questions that arise because sometimes in a test you might get a question like this one right here. So you're given the hypotenuse as well as the run, but you do not have the rise. So this is an unknown value. So this can get a little bit tricky if you do not follow along correctly and if you don't take the correct steps as you're meant to. So I'm going to show you step by step what you're going to do. If you think back to Pythagorean theorem, you're going to remember that to find the hypotenuse, you're going to do a squared plus b squared equals c squared, where c squared is the hypotenuse. But here we already know the hypotenuse, so knowing that, you're going to change it. So it's going to end up being a squared, we're just going to say that this unknown value here is a squared, equals b squared minus c squared, because you're changing the direction of the flow. Okay, so we're going to do here a squared equals b squared minus c squared. So kind of like that. Okay, so we're going to say that this is side A, this is side B, and this is side C. Okay, so your next step is you're going to substitute the values that you know. So a squared equals 20 centimeters squared minus 15 centimeters squared. So it's going to look like this right here. That's your next step. Now you're going to square the stuff, okay? So it's going to be a squared equals, this is when you pull out your calculator, and it should be here somewhere because that would be really convenient to find it. Okay, so if your equation looks similar to mine, a squared equals 400 minus 225. You're still on the right track. You still have hope. Okay, so now we are going to subtract the value. So that's 400 minus 225, and that gives us 175. Okay, so a squared so far equals 175. But that is not our answer yet because we actually have to turn it back into square rooting. That's the term that we're looking for. So if you square root 175, you will get 13.2. Okay, so A equals 13.2. Just like so. So that means that this side here is 13.2. And now you can find the slope of this triangle. Perfect. So now you know how to do slope. No matter what values you're given, it's gonna work out. Don't worry. So now we're gonna move on to tangent ratio. Okay, so the tangent ratio essentially is just your way of finding unknown angles. So what we have here is this triangle. On side B, we have 3.9 centimeters, and then on side A we have 2.5 centimeters. So the first thing that we're going to do is we're going to find the hypotenuse, because that's easy. C and B, this angle here, well actually it's angle C, it's 90 degrees. You already know one of the... So what we're going to do is a squared plus b squared equals c squared, and we already know how to do that because we just went over it right now. So the hypotenuse is 4.6 centimeters. So this value here, the highest, this little slanted one here, it's 4.6, so we can write that in. So let's say we're looking for the angle of, well actually it's, you see, we're going to look for this one here, tangent A. So this is exactly how we're going to do it. You're going to call it tangent A on your paper. It just makes it a lot easier. So tan A equals, and you're going to do opposite over adjacent. And if you don't know what that means, I'll tell you right now. So opposite is the side that is opposite of the angle. So it will be this one, A. And adjacent means that it's, you know, like connected. It's right here. Okay, so A equals opposite over adjacent, which is 2.5, I think. Yeah, and 3.9. So we're just going to write that in. Tan A equals 2.5 over 3.9 centimeters. Okay, so that's what we've got. And now you're going to do the inverse function to find the angle. So tan is actually, the tangent is a function on your calculator, but there's a reverse or inverse kind of, you know, same thing, but it's the opposite. I don't know what it means. I don't really know. It's just on your calculator, and it just happens. So you're going to rewrite this as A equals tan the minus 1, 1, because it's the inverse operation function. And then you're going to stick in your numbers that you know. And you're just going to put them in brackets because this is also a function. Okay, so A equals tan the backwards 1 times 2.5 over 3.9. So just going to grab our calculators and we're going to, you know, figure that out. The answer should be A approximately equals 32.7 degrees. Alright? Just like that. And so that's this. That's the angle of this. And that's all you really need to know, unless you wanted to find B, which you would do the exact same thing, because now you also have the other angle, but you can also remember that all triangles have 180 degrees, so you would really just add the two angles that you know together and then subtract that from 180, and that's how you'd find the last angle. So yeah, I hope you found this video informative, and I hope you enjoyed, and I will see you later. Thank you for watching, Professor Math. Have a great day.